have the honor to, or I have the honor to introduce Alan Akbik here as our speaker for the next session. Alan is a leading expert in natural language processing and large language models, and he is professor at the Humboldt University to Berlin, and he works on different topics like transfer learning, few-shot learnings, and semantic parsing. And today, Alan will share his insight on large language models, challenges, and opportunities. Please join me in welcoming Dr. Alan Akbik to the stage. Thank you.
Hello, hello, hello. Yeah, okay, great. Yeah, thanks. Thanks very much for welcoming me here. Yeah, today I'd like to talk about evaluating the factual knowledge of language models. And this talk is basically coming from a paper that we're going to present at NACO. It's from my students, Jacek and Max. And so the outline for today is I would like to first give you a bit of motivation. So why are we interested in evaluating language models? I want to talk about continual pre-training and catastrophic forgetting. And then, after we've had the catastrophic forgetting, I want to talk about factual knowledge in large language models. How do we evaluate this? And then finally, once I introduce our evaluation framework, I would like us to have some fun and rank LLMs with something that we developed, the language model pub quiz, which looks something like this. And maybe a question for the room. Who has already participated in a pub quiz? Okay, so everybody, okay, I can see Bayer is a fun company. So yeah, in a pub quiz, right? So you go into the pub and they ask you a bunch of questions and they count how many times you got the correct answer. And we're going to do the same thing with language models. And to start off, let's start with some trivia, something that you might actually hear in a pub quiz. It's a super easy question. Who is the Chancellor of Germany? Okay, so this would actually be a super easy pub quiz. It normally wouldn't happen. But actually what is interesting is that we actually asked this question to ChatGPT only like a week ago. And ChatGPT gave us a very interesting answer, namely, it was on the 2nd of April. Oh, okay, it gave us this answer. Angela Merkel, right? So, but the interesting thing is that actually it's explaining why this happened. So I guess my slides have somehow been messed up. Oops, yeah, because the last update of ChatGPT, this particular model was in January 2022, right? At this point, it wasn't true, but it wasn't super wrong, right? And so why is this happening, right? Yeah, so what's happening here is pre-training, right? So what happens is you take your language model, you train it from scratch on very large data sets. This is very expensive on a lot of data. So for instance, you would train it on Wikipedia, corpus that you have until 2022, web crawls that you've crawled up until this particular point, and this gives you a language model up until this particular date, right? And so what you now do with continual pre-training is that you take this existing language model and you essentially continue pre-training it. So you take new text data, let's say some web crawls from 2023 and 2024, you continue training this existing language model in the hopes that it gets new knowledge. Yeah. And so the nice thing about this is that you can reuse this existing language model. You don't need so much data and maybe it's not so expensive anymore. Yeah. But actually, continual pre-training, what most people are interested in is a domain adaptation, right? So you take an existing language model that was trained, let's say, over general domain corpus, Wikipedia, web crawls, and it can kind of answer all sorts of questions. But you, maybe as a company like Bayer, you have very specific domain that you're interested in, right? And so you take your biomedical text data or some data that you have, you do continual pre-training, and then you adapt this language model to be very good for biomedical questions, right? And so this is domain adaptation of an existing language model. And so this could potentially work actually quite well, continual pre-training. However, there is a risk or an issue, and that issue is called catastrophic forgetting. So in this case, what happens is you train your existing knowledge, you teach it something new, but at the same time, it's forgetting a lot of the old stuff. So the internal distributions of the models are shifted catastrophically in such a way that it's actually not useful anymore. So for instance, it could learn that Scholz is now the chancellor, but it would forget 100 different other things, right? And so as we're doing research in making continual pre-training more robust, we realized that we require a reliable way to measure learning and forgetting of factual knowledge. Yeah, during continual pre-training or in general, we just want to know, is this model learning new knowledge? Is it forgetting knowledge? We just simply need to know. And so our desiderata were, we want a knowledge probe that works with any type of large language model, because there are different types, right? It should cover a broad range of knowledge. It should be fast and it should be accurate. Yeah. And that brings us to the second part, factual knowledge and large language models. So we're particularly interested in factual knowledge. And what this means is that we consider facts as relations between subjects and objects. Yeah, and a standard example here would be, oops, where is it? Yeah, again, I'm sorry about this. So the conversion has somehow messed up my slides. But essentially, one relation would be something like, which place has which capital? So you could imagine a table like Germany, Berlin, Nebraska, Lincoln. And if you have such a table, you could automatically create a knowledge probe that is asking the language model, what's the capital of Nebraska? And you check whether the answer is Lincoln, and that's correct, right? Or you could ask something like, which bridge crosses which river, right? So, I mean, there could be anything, right? So for instance, you could ask, which river does the Charles Bridge cross? Or you could ask the other way around, give me a list of all the bridges that cross the Rhine, right? And the nice thing about this is that there are existing repositories of factual knowledge, like Wikidata, where you have essentially these tables. You can get these tables and you can automatically construct a knowledge probe to test your language model whether it can answer this type of question. Yeah, and so the most used probe is actually the Llama probe. It's the one that everybody is using, and it works like this. So again, yeah, the animations are a little bit messed up, but essentially you start with an entry in this table. Then you create a sentence out of it where you mask out the answer. So you would say France, Paris, and you would create a sentence that goes like this. The capital of France is Mask. And then you take an existing language model and you make a prediction. Yeah, and you test whether the language model is predicting the correct subtoken for this masked out word. Yeah, and yeah, okay, now we're gonna. So if the prediction is correct, you get a point, and if the prediction is incorrect, you lose a point. Yeah, so it kind of works like this. And you repeat this for 30,000 Llama facts, and then you have like a nice overview of the knowledge that your language model has. Yep. However, there are a lot of limitations to Llama, and this is kind of the starting point for our work. So one big limitation is actually that it's limited to single subtoken answers. Because the language model can only predict a single subtoken for this mask token, it has to be in the vocabulary, right? And the vocabulary is very limited. This means that you can't actually ask very interesting questions. The other problem is that it's limited to masked language models because it is reusing the pre-training objective of masked language models. But there are different types of language models, and those you could not evaluate with this probe. There's other problems. So other prior work has found that there's a biased distribution of answers in a biased domain. That means your language model essentially gets more points if it happens to share the same biases, which is not good. And also there are some issues with some questions where some questions give the answer away and other things. So there's actually a long list of things that we discovered or other people have discovered, and they're described in detail in our paper. And so to address this, we developed the BEAR probe. And the main idea here is to formulate it as a multiple choice item. So rather than a single subtoken mask prediction problem. So essentially what we do is for each fact, we give the model 25 different plausible answer options. Yeah. So for instance, if we're asking for the capital of Uganda, we give it, so we only illustrate 4 here, we give it 25 different options that could somehow be plausible, right? And now what we're doing is we're using the language model. For each answer option, we create a textual statement, and we're using the language model to compute the log likelihood of this textual statement, right? Because every language model can do that. And then we do a ranking, and we choose the answer with the highest log likelihood. Essentially, the sentence that most matches the distributions that the language model models is the correct answer, or the answer that the language model chooses, right? And the nice thing about this is that any language model can estimate log likelihood, right? If you have a causal language model, it's very easy. So you just compute the individual probabilities of each token in a sentence. If you have a masked language model, it's a little bit more effort, but it's also possible. You have to mask out each individual word in the sentence and then compute the probabilities again, right? And so together we have this probing mechanism based on log likelihood that addresses the problems that it can now be applied to any language modeling type and has no limitations on the answer space. And at the same time, we developed a probing data set that addresses these issues of biases in question quality. So we released it in 2 variants. We have one that has about 8,000 questions, that's the main one. And we have one with 41,000 questions, that's the big one. Yeah? Okay, that brings us to the pub quiz. So now what we're going to do is we're going to take a bunch of language models. So we decided, so in our paper, we looked at language models that are available open source, and that's kind of interesting. So we looked at Llama 2 in different sizes, at Mistral, at Gemma in different sizes, OPT, and also a bunch of classical models like GPT-2, BERT, and Roberta. And we, in case your favorite model is not in this list, could be, right? In this case, we released an easy-to-use software package that is called LM-PubQuiz that you can use to test your own models. So the software package is installable through pip. It's actually just a few lines of code, and it works directly with any Hugging Face model. There's a website that explains how to use it, but really it's just like 5 lines of code, and you illustrate the Hugging Face model name, and it will output the Bear score for the model. Yeah, and so this is now the evaluation results. That's a little bit, I'll explain this graph. So we have the accuracy, that's the score on the one axis, and on the other axis, we've plotted the model size, right? So the models that we tested go from 100 million parameters to 30 billion parameters. And what you see are the different model families. So the OPT families, that's the red line, right? That's going through this graph. And you see also, well, the other ones, Mistral, Llama, and so on. And so we make a bunch of observations here. And one observation that's probably not super surprising is that larger models are generally better. Yeah, so you can see as we go to larger model sizes, it's scoring much better on the probe, right? So that's clear. But what we also notice actually is that size isn't everything, right? We notice that Mistral, if you look at the 7 billion mark, so I don't have a laser pointer on this thing, but if you look at the 7 billion mark, you see that, for instance, that the newer models, Mistral, Gemma, they're outperforming OPT by quite a lot, right? So even though these models have the same size, the newer models are actually much better. And one reason possibly is that because they're trained over much more data. Yeah? Another thing that we've noticed is that masked language models tend to outperform causal language models. So we only evaluate masked language models of small sizes, but if you look at the other end of the graph, you're seeing that Roberta, for instance, if you compare Roberta versus OPT, you're seeing that there's a slight edge to masked language models, which we thought was actually kind of interesting. Yeah, so as I mentioned, we released this knowledge probing framework, LM-PubQuiz. We have a web page with a leaderboard where you can see the current Bear scores for all these different models, and you're very welcome to try our library and to evaluate your own models. So to summarize, I've presented a new framework for evaluating factual knowledge in LLMs. It addresses problems of prior probes, biases, limitations in the questions and answer space, and it's applicable to any type of large language model. One of the next steps that we want to do is we want to extend this question catalog for scientific domains, because what we're currently working on is we are doing continual pre-training where we take a general domain model and we train it on scientific domains. And essentially what we want to use this framework for is to see, is it learning knowledge about the scientific domains, and is it not forgetting knowledge of the general domain, right? So this is what we're hoping for. And yeah, so that's what we're adding to the framework. It's released as an open source library, so do try it out. And that's that's it. So, any questions?